Let's say I have a perfectly smooth floor and my favorite yellow ball again. Now, if I push this ball with a certain force and the ball moves for some distance, say for a distance of maybe S or D, okay, D, then when it reaches here, it would have accelerated to a certain velocity v. Okay. Let's say the mass of the ball is m. Now when it has reached this velocity v, its kinetic energy would be half mv squared. Now we know that the work done is given by the formula Fd, force times the distance. Now we also know that the kinetic energy is given by the formula half mv squared, and that they are equal. Okay, this is the kinetic energy, and they are equal. The question is that I want to answer now is why? Why are they equal? Right. So this I'm going to show how to actually prove that they're equal. Now in the first step, I shall think about the acceleration. Okay, as the force pushes the ball accelerates. Let's say the acceleration is a, and let's say that at first the ball starts from rest. Okay, just make it simpler. The ball starts from rest, and after a time accelerates for time t, the ball reaches this velocity v. Okay, now let me start by writing down the two main formulae that I shall need. I need a formula to relate the force to the acceleration, and I need a formula to relate the acceleration to the distance, maybe time and velocity. So that's here we go. Relating force and acceleration, we have Newton's second law, F equals to ma. Okay, and relating acceleration and the others, there are a number of formulas for acceleration, number of equations we can choose from, and let's see now which is better in this case. I think this one. It's always a bit tricky which one to choose, and sometimes it's a bit of a trial and error. Basically to find something that you can use. Okay, there's one that goes like that, right? V squared is equal to u squared plus 2as. Okay, I think that's the formula for 2as. Now in this case, the s is my d. Okay, so I'm just going to call this 2ad. Okay, and in this case also, the ball starts from rest, so my u squared here is actually 0. So this is actually 0. All right, getting there. So Now I want to show this, right? Fd is equal to this. Now what is the best thing to do? Okay, first let me just cross this out since it's 0. Cross this out. Now the next thing to do is to maybe make use of this and substitute it into the, say, the left hand side of this equation and see whether it will give me this half mv squared. So I'm just going to start from fd. Now from f equals to ma, we know that we can, if we rearrange this, I don't have to rearrange this, right? I just have to substitute ma into the fd. So starting from here, starting from fd, okay, let's work through this. F is equal to ma, so this is ma. Okay. Now I need to relate a to v, and I can actually do it here. I have this equation that relates v to a and d actually. So I've missed out. F was ma. Okay, so I still have a d there to put in. D. Okay. So right. See, I have AD here and I have AD there. So what a nice coincidence. So this means that I can now say that because v squared is 2ad, I can now express ad in terms of v squared, because this means that ad, if I divide both sides by 2, this means that ad must be equal to v squared over 2. AD is equal to v squared over 2, and I have AD here, remember? So therefore this is v squared over 2, v squared over 2, and here we are, mv squared over 2, exactly what I set out to prove. So that's quick, right? So we got it. We have just shown that the work done Fd here is equal to half mv squared, our formula for the kinetic energy.